All right, class, this is Miss Riggins with today's message on another section of conic sections, which is hyperbola and plural hyperbolas, which is from section 14.4. If you remember from previous videos, hyperbola is a curve that can be constructed by slicing a cone in a special manner. Unlike the slicing that produces a circle or an ellipse, this slicing is a vertical slicing, and it cuts into both pieces of a two by two cone structure. So as you can see, we have this upper curve and we have this bottom curve. They are all are part of the same function. Well, actually same curve, which we call a hyperbola. And sometimes if you orient the cone in a vertical manner, you get a hyperbola that looks like this. And if you turn this physically so it's a horizontal cone and a horizontal slicing, you get a figure that looks like this. Each piece of each curve is called a branch of the hyperbola, and they are separated by a center point. And then we have these slanted asymptotes that basically define the curve as well. And we can use this information to determine what A and B are, but more on that a little bit later. So where do hyperbolas come from? Let's take a look. If you remember the trigonometric identity, sine squared plus cosine squared is equal to 1. We can also produce another trigonometric identity by dividing everything by cosine squared. When we divide everything by cosine squared, we end up with another trigonometric identity, tan squared plus 1 equals secant squared, or I can do some algebraic manipulation and get secant squared minus tangent squared is equal to 1. Well, that looks very familiar. If I let x be secant of t and y equal tangent of t, then I'm going to end up with something that looks very much like a parametric equation. And in this case, if I solve for, eliminate the t, then I get that x squared minus y squared is equal to 1. Or y squared equals 1 minus x squared. But this looks very much like a ellipse equation, with the differences, of course, in the tangent, in the secant and tangent, but also over here in the implicit form, it has a minus instead of a plus. And in the plus, you'll have that for an ellipse, but for a hyperbola, it's minus. And of course, I want to point out that the right side can be represented where it's only 1, and that's the ideal situation. So how does this affect our example? Well, we can generate, in this case, this was a very general hyperbola with the center being at 0, 0. So let's see what happens if we change the location of the center. And so over here in our notes, in the book, it gives us the formula very similar to that of an ellipse. We still have x is equal to h plus a times some trigonometric ratio, and y is equal to k plus b times some trigonometric ratio. In an ellipse, those trigonometric ratios are cosine and sine, but in a hyperbola, it's secant and tangent. Okay, so it looks very similar to the parametric form of the ellipse, with the only difference being that we have secant and tangent instead of cosine and sine. And we still have the same conditions that t is between 0 and 2 pi, and a and b are positive numbers, and that makes life a lot easier for us. So to get to the standard form, i.e. the implicit form, we have what we already proved a little bit earlier. We have the x minus h quantity squared minus y minus k quantity squared is equal to 1, and that's in the case that we have a hyperbola. You have a minus, but we have one more additional thing, which is that in the denominator it's a squared and b squared, very similar to that of an ellipse. And if you remember, for an ellipse, the a represented the horizontal axis, which was 2a, and the b represented the vertical axis, which was 2b. And so in this case, just like in an ellipse, it's a squared over b squared. Okay, so we will talk more about this a little bit later, but in your home learning assignment activities, you're going to have to be able to write an equation of a hyperbola in either parametric form or implicit form, and you're going to have to be able to draw a hyperbola if they give you the implicit form or the parametric form as well. Okay, and I think that will be it. And also, yeah, so do that for their home learning assignments, and then I think you'll be really prepared and for the video learning assignment, video assessment. Okay, have a good day.